Okay, this lesson is the last part of a three-part series of lessons on pressure. So in this lesson, we are going to talk about the last two parts of the frequently asked questions that students ask about the chapter on pressure. So we'll be dealing with the first one is what is mmHg and how do we convert mmHg to other kinds of units. And the next one is how do we understand the ideas behind barometers and manometers. So first of all, let's talk about what is mmHg. mmHg is actually a form of unit for pressure. Okay, just like Pascal or Newton per meter square are also units for pressure. mmHg simply means millimeters in height of mercury. All right, millimeters in height of mercury. So what exactly is mmHg and how do we derive it? So first of all, let's recall that the pressure of fluid is given by the formula H rho g. Okay, this means that the liquid pressure is dependent on the height, H, the density, rho, and also the gravitational field strength G. Okay, it is not dependent on other factors, especially the area of the container. Alright, so if you look at this diagram below, you will realize that if I ask you to find the pressure at the bottom of all these containers, this is a container of a very narrow rectangular shape. This is a broader rectangular shape. This is like a cone. This is an inverted cone, and this is an irregular shape. Okay, regardless of the shape of the container and regardless of the bottom surface area, okay, the only dependence in this case is the height or the depth. So in other words, if they all have the same height or the same depth of liquid, all right, and this is a liquid of the same density and they are at the same location on Earth with the same gravitational field strength, then you will expect that they will have the same pressure at the bottom of the depth. Okay, so let us calculate. So since pressure is equal to H rho g, okay, since both density and G are constant for the same liquid at the same location on Earth, okay, we can simply express the pressure in terms of the height of the liquid. That means that we can ignore the information about the density. Let's say this is mercury and G, because these two are constant for all the locations that we are taking the reading of the pressure. All right. So so in other words, okay, apologies, just go back to this first. In other words, the pressure in this case can be expressed simply as 20 millimeters of mercury or 20 mmHg. So what does it mean? Okay, it means that if you want to convert this tree, let's say this tree into Pascal, how will you do the conversion? All right. First of all, I would like you to pause the video and try it yourself before I give you the answer. Okay, so have you done the questions already? Let's start. So as you know that the pressure of a fluid is related to the formula H rho g, and then this unit is simply expressing the height or the depth of the mercury. So in this case, you have a depth of 500 millimeters of mercury because this is mercury. So that means that it is 0.5 meters of mercury multiplied by 13,600 and then multiply by 10. So in other words, I can simply use H rho g to convert to Pascal. Okay, and the reason why I'm using 13,600 is because I know that this is mercury or Hg. All right. So similarly for the second one is 27,200 Pascal, and for the third one is 136,000 Pascal. And you realize that the mmHg conversion is not restricted to only, but you can also use centimeters and meters, because this is just an expression of the length. So you can use different units of length in this case, all right, but the mercury is the same. Okay, so how about do you know how to convert the opposite? How can you convert from Pascal to mmHg? Okay, you may pause the video at this point in time and try it. Okay, so have you found the answer already? So because we know that it is related by the formula H rho G, so we just do the opposite. Okay, because H rho G will give you 9520. So you have to divide by rho and G to find the meters or millimeters. So when you first divide, okay, you will find it in meter Hg. So if you want to convert to mmHg, you just do the next step, which is multiply by 1000, you get 70 mmHg. Okay, similarly for the next one, all right, you do the same thing, divided by 13,600 times 10, you get in meter Hg, then you convert to mmHg. Okay, so what is the benefit of using mmHg? The benefit of using mmHg is that you can simplify the calculation of pressure by just simply subtracting the distance between the points. Okay, let's say I want you to calculate the pressure difference between point AB and point BC. Okay, you may pause the video at this point in time and try the question first. Okay, so have you done the question already? So the first question, A, B, what's the pressure difference? So first of all, you know that AB is this distance here, okay, and that from the surface to B is 60 mm, and from the surface to A is 20 mm. So in other words, the pressure of A is 20 mmHg, the pressure of B is 60 mmHg. So the pressure difference is simply 60 minus 20. So it's 40 mmHg. Alright? So similarly, if I want to find the pressure difference of B and C, I will just have to add up these two lengths, 50 plus 20, to get the full depth of C minus the depth of B. So the depth of C is 70 mmHg, while the depth of B is 60 mmHg. So you will get 10 mmHg. Alright, so it's that simple. It's just a matter of subtracting the lengths. Okay, so since by knowing the height is enough to determine the pressure, we can express other fluids in the same way. So we know that we can express as mm, meter and cm. Do you know that we can also express as, for example, let's say we have water instead of mercury, okay, and let's say we have 20 cm of water. We can in fact express the unit as 20 cm H2O, okay. So then you'll say, how do we justify it and how do we prove that we can express in this way? Okay, you see, as we have already shared previously, right, the density and the G is always constant. So how does this unit tell you everything about the pressure? First of all, this 20 cm tells you the height or the depth of the water. And this H2O tells you what material. Okay, in this case is water. So with this information, straight away you know that the H will be 0.2. Water is identified with a density of 1000, and we know that G is always 10. So that's why you get 2000 Pascal. So that means that with this information, immediately you can find the pressure in Pascal. Alright? So you can even express as other things like ethanol, methanol, or whatever chemical compound liquids that you can think of, and it will also work. Alright? So let's move on to the last part, which is barometer and manometer. Okay, in order to understand the mechanism of barometer and manometer, we must first approach the question, how do we drink from a straw? Okay, I want you to think for a moment before you answer this question. Okay, you may want to pause the video. So have you found the answer? So a lot of you, when approached with this question, will always say things like, oh, because we suck the liquid into our bodies. But the true mechanism behind drinking is not due to us sucking the liquid. All right? The true mechanism is due to the pressure difference between two regions. And it is due to this pressure difference between these two regions that cause the movement of the liquid into our body due to the need for balancing of the pressure. All right? So let me just explain using a diagram. Okay? First of all, when we drink, we expand our lungs. So when we expand our lungs, we reduce the pressure in our body because there are lesser air inside in a larger space. All right? So when the pressure outside will be now higher than the pressure inside our body. Okay, so in other words, the air pressure outside is now higher, so it will act extra pressure from the outside, pushing the liquid down the straw and into our body. Okay, so in other words, now the pressure here is lower, now the pressure here is higher. The pressure here pushes down more than the pressure here acts here. So there is a resultant pressure pushing the fluid into our body. Okay. So with this information, okay, we can look at the idea of barometer. Let's say you have a tube that is sealed up at the top, and you invert this tube into mercury. All right. And let's say this tube is vacuum. There is no pressure, no air, nothing in this tube. All right. So what happened is that there is a imbalance of pressure again. Okay. Inside, no pressure. Outside, atmospheric pressure. Okay. Because the pressure in the tube is zero, while the atmospheric pressure is high. Okay. The pressure difference will force the mercury up to rise in the tube until it balances the atmospheric pressure. Okay, so it will keep rising until the point where the atmospheric pressure is equal to the pressure exerted by this height or this depth of mercury that has just risen. All right. So when the mercury level has stopped rising, the height of the column of mercury exerts an equal pressure to the atmospheric pressure. That means that this height from the surface to the top surface, okay, this height is exerting a pressure that's equivalent to the atmospheric pressure. That's why it doesn't rise anymore. They reach a new balance. Okay. So when this happens, you can straight away calculate the atmospheric pressure by simply measuring the height. Remember mmHg? That means you can just simply say, okay, this is 760 millimeters of mercury, and that is the atmospheric pressure. Okay? So it's that simple. It is just pressure difference causing the pressure to want to balance, and when it balance, you can use one side to measure the pressure of the other side because they are equal. Okay, so let's try this yourself. Okay, give yourself some time to do. Pause the video now. Okay, so have you found the answer? Okay, so you must remember that the pressure exerted at point A, B, C, right, is what is above the point, okay, not what is below. Okay, so that means that pressure at A, right, the pressure is zero because there's nothing above it. This is all vacuum. Okay, when it is vacuum, there's nothing. Okay, there's no pressure. Now at B, it will be 30 cm of mercury and not 46 cm because it is how much that's above B that matters. So at B is 30 and at C it will be 76 cm Hg. Alright. So if I want you to measure the atmospheric pressure will be the pressure reading at C, because at C you will have the same position or the same level as the outside surface. So that means that this height of liquid from this surface to C has a pressure exerted at C equal to the atmospheric pressure. Alright. So let's move on to manometer. When the pressure on, okay, so we learned about barometer. So the idea of manometer is very similar, but instead of having an inverted vacuum tube, we have a U tube. Alright, so how does it work? Okay, when pressure on both sides of the manometer is the same, the liquid in the manometer has the same level on both sides of the tube. That means that if let's say this is mercury, and this is atmospheric pressure, and this is gas, alright? So if this pressure is acting the same as this pressure, both gas and atmospheric pressure are equal, these two levels will be the same. Okay, these two levels will be the same because they have to have the balanced pressure on both sides. But what happens if you have this case? Okay, when now the gas pressure is lower than the atmospheric pressure, okay, the liquid will be pushed down on the right side and up on the left side until the pressure balances. So that means the atmospheric pressure will keep pushing it down here, and this side will keep rising, and then until it balances. Why will it balance? Very simple. This column of liquid now helps this gas to act against the atmosphere. That means that the atmosphere pressure is acting down on this liquid, and then this extra liquid that has been pushed up here now contribute together with the gas to push backward. Alright, so how do you find the pressure difference? So this additional gas that helps to push backwards, that eventually balances the pressure of atmospheric pressure, is the height difference. Okay, is the height difference. Okay, so what happens is this: the pressure of gas here plus this height difference, H rho g, will give you the atmospheric pressure, PATM. Okay, so how do you find and how do you locate the point of reference where you take the height? Very simple. You look at the gas, okay, you look at the liquid. Let's say this is mercury, okay, so you take the point of the mercury surface at the lowest point. So these are the two surfaces. You take the lowest point, and then you draw a line. You draw a line through the whole thing. So this point is your reference point, because anything below here on both sides of the U tube, they have the same liquid. So anything below here, they are balanced. So this is your reference point. The height that you need to take is from this reference point to the surface of the mercury on the other side. Okay, so this will be your height. So that means that P gas plus H rho g, rho is the density of mercury, g is gravitational field strength, will be equal to the PATM. Okay, so this is your reference line. So in the same way, if let's say the pressure in the gas is higher than the atmospheric pressure, the liquid will be pushed down on the left tube and upright in the right tube until it is balanced. Okay, so again, the height difference represents pressure difference on both sides, and in this case, the P gas, okay, will be equal to PATM plus H rho g. Again, your reference point is here, and this will be your height difference. Alright, reference line is here and your height difference. Okay, so now I want you to test yourself. Can you find the pressure of the gas in terms of the atmospheric pressure? In terms of mmHg. Okay, in terms of mmHg, given that the atmospheric pressure is 36 mmHg. Okay, you may pause the video now and try this question. Okay, so have you found the answer? Okay, let's look at the answer. First, you draw the reference line. The reference line must be the lowest point in the mercury. So it will be at this point. Then after that, you look at the height. The height from the reference line to the higher level is 5 cm. And then you know that because this side is being pushed down and this side is being pushed up, so the pressure of the gas is higher than that of the pressure of the atmosphere. So using the reference line, you know that the left side pressure above the reference line is equal to the right side pressure above the reference line. So that means that the left side you have P gas only, on the right side you have PATM as well as the column of the liquid plus H rho G. So in other words, you get 81 mmHg. Okay. Alright, so that is the last parts on barometer and manometer. Okay, if you still have any confusion, because this is a very summarized explanation of this idea of pressure, I may come up with another video on some specific areas. Okay, but this at this point in time, this will do. If there is any issues, do let me know and I will come up with better explanations in the future. Thank you and have a nice day.